This is the sixth robotic lecture of CAM 810S. The topics are sensors, machine and robot vision, and periphery. Tactile sensors are also called microswitches. As the name indicates, these sensors emit a signal when the lever to the left or the button on the diagram to the right, thermoplastic actuating button, is actuated. They have two types of contacts, normal closed, NC, and normal open, NO. On the right side of the diagram, you see the terminals. There is always a common terminal, that's the one below, and then O terminal and an NC terminal. They are widely used to limit movements, monitor part placement, and restrict access, among others. Other tactile sensors are based on determined physical properties. In strain gauges, the electrical resistance of a coil changes when deformed. In piezoelectric sensors, a piezo crystal, that's a quartz crystal, produces a voltage when it is deformed. That means when a force is applied to it. Both sensors are used to force detection. Excuse me. Both sensors, of course, are used for force detection in grippers or end effectors, for instance. There are several types of electronic proximity sensors. Inductive proximity sensors change their magnetic field when a metallic object approaches. The increasing electric current triggers a signal. The detection range is within 50 millimeters, and inductive proximity sensors are used to find out metals, steel, aluminum, and others. The capacitive proximity sensor detects objects of any material. This is the big advantage. An electric field is modified, and this triggers a signal. Capacitive proximity sensors are used for detection of plastic materials, wood, paper, but also metal, any type of material. Also, in this case, the maximum distance for detection is 50 millimeter. There are two types of optical or photoelectric sensors. The one-way photoelectric sensor has a transmitter which sends an infrared light beam to a receiver. Transmitter and receiver are in separate casings and distance from each other. When the beam is interrupted by an object, a signal is released. The application is for short to medium distances up to maximum 2 meters. In two-way photoelectric sensors, transmitter and receiver are in the same housing. When the beam is reflected by an object, a signal is released. They are used for short to medium distances up to 2 meters. The big advantage is that they are very compact and less cabling is needed as compared to the one-way photoelectric beam. Ultrasonic sensors emit ultrasonic waves, that is, waves of a very high frequency. When the waves are reflected by an object, a piezo crystal produces a low voltage because it is a kind of force which is applied to it. So we repeat, a sender transmits ultrasonic waves of frequencies between 50 to 200 kilohertz. The object reflects the waves. The receiver captures the echo and transforms it into signals. Applications: ultrasonic sensors can be used in any reflecting materials. The maximum distance is 3 meters. They are often used for measuring or detecting distances in bottles, for instance, which are filled. We'll see an example later on. Now here are a few examples of sensor applications. On this palette, there is a lot of materials, and the height of the palette is monitored with one-way photoelectric sensors. The transmitter to the right and the receiver to the left. This is the example of which I spoke before. The charging level of liquids which pass on a conveyor are checked with an ultrasonic sensor. This is an example of monitoring an entrance to a robotic cell with a micro switch or with several micro switches. And this is quite an interesting example. Parts, metallic and non-metallic, are moving on a conveyor. And the inductive proximity sensor detects the metallic parts, which are then ejected, whereas the non-metallic parts pass. Force monitoring on a bionic hand, probably with strain gauges. This is the monitoring of wood in a lock feeder of a sawmill with capacitive proximity sensors. This is another interesting example. The sag size in a plastic sheet production line is measured with an ultrasonic sensor. The sag is the one which drops below the two the rolls. It must be always at a certain distance. In this example, springs on a pallet transfer systems are monitored with a two-way photoelectric sensor. Now to machine vision. Machine vision means automated extraction of information from digital images. In machine vision systems, information regarding shape and position in space are used for inspection. Here, pills in their packings, which pass below the camera. The two yellow ones are missing and will be later on ejected. Measuring and gauging. Identification. And robot guidance. That means a robot may pick randomly placed object after being recognized by a machine vision system. That's how it works. Machine vision cameras are equipped with so-called CCD sensors. CCD is short for charge-coupled device. Liquid quanta, that means extremely small parts of light, strike the CCD pixels. Pixel means picture element, which releases then electrons. The electron charge is digitized and sent to a computer which processes it. Quality of a CCD sensor is defined by its resolution, which is indicated by PPI, pixels per square inch. It's clear that the resolution to the left with 10 ppi is much inferior to the resolution to the right with 20 ppi. A modern CCD camera has got hundreds and thousands of PPIs. Now the machine vision for robot guidance functions like this. It's quite an interesting application. A conveyor transports objects in the direction indicated by the arrow. In a first step, the image of the object is captured by a CCD camera. A light source provides good illumination. In a second step, a so-called frame grabber situated in a controller processes the image and compares it with previously defined shapes or pattern. A monitor visualizes the object for the operator during setup and operation. The robot coordinates or the coordinates of the object are then transferred to the robot arm, which picks the object. All this is going on, of course, in a very short time. Here is a CCD camera with a circular illumination around the lens. The conveyor transports the objects, and the robot arm follows with the same speed. And the gripper picks the object. On the upper left, the X and Y coordinates of the object are displayed continuously so that the operator can check the process. It's also very important when such an application is set up to have this information. Now, this is an example. A fast-moving Delta robot picks randomly placed biscuits from a conveyor after they were baked in an oven. It means the conveyor moves through the oven in a very slow speed. The grayscale image to the right displays the sequence of picking the objects. You see they are numbered. This is going on quite fast. There is a very good video on this application later on to be watched by you. The next topic is periphery. You are already familiar with some periphery devices which you studied in CAM classes. That's then just a repetition and a completion of what you have already studied. Periphery stands for all devices in the environment of a robot or a robot cell. There is raw material storage. There are raw material feeders. Finished parts must be stored. There are part transfer devices. There are part separation devices. Remember the vibratory ball feeder. There are part positioning devices. And there are clamping devices and many others. These are just a few examples. Just an example which you can look at in the laboratory. This is the gravity feeder for prismatic parts in our laboratory. The presence of a part at the end of the feeder is monitored by a microswitch. The same feeder can be adapted for cylindrical parts, and the monitoring of the part which is to the right below is also done with a microswitch. These are raw material. This is raw material storage and picking. And this is placing of finished parts on pallets. Now, a few more informations about transfer systems. This is a double belt transfer system which has got an angular structures. That means no curves are possible. The pellets pass from one section to the other in the direction of the arrowhead. Each section has its own drive. This is how a station looks. The pallet arrives. A pneumatic piston stops the pallet so that the object which is on the pallet can be picked or placed or whatever. In another design, this one, a flexible chain transfer system allows for curves. And on this workpiece, carriers, they move on a simple belt conveyor. A robotic cell is equipped with a similar conveyor. Finally, some impressions of robot applications. Cars are assembled at a BMW plant in Munich, Germany. This robot handles sheets which are processed at a bending machine. The sheets are held by vacuum grippers. And this robot picks objects from a conveyor and places them in a cardboard box. This is the end of the 6th robotic lecture. Watch the YouTube videos and make your exercises. Thank you for your attention.